Hey there, welcome back to the channel. Today we're diving into solid principles, and more importantly, the one principle that almost everyone misunderstands. And spoiler alert, it's probably the one you think you understand the best. If you've ever wondered why your perfectly solid code still feels wrong, stick around, this might just blow your mind. So the setup. Solid principles, right? 5 letters, 5 rules to write better object-oriented code. Created by Uncle Bob Martin and treated like gospel by developers everywhere. And here's the thing. One of these principles is consistently misapplied in ways that actually make code worse. And I'm willing to bet you've done it. I know I have. So the culprit, the Liskov Substitution Principle, or as I like to call it, the one where everyone makes squares inherit from rectangles and then act surprised when the math breaks. So, quick recap. Before we get to the drama, let's recap all 5 principles. S is for single responsibility principle. A class should have one reason to change. O is for open and closed principle, open for extension and closed for modification. L, Liskov substitution principle, subtypes must be substitutable for their base types. I, interface segregation principle, don't force clients to depend on interfaces that they don't actually use. And D is for dependency injection. Dependency inversion principle. Depends on abstractions and not concretions. Easy enough, right? Well, let's go. So let's zoom in on our troublemaker, the Liskov substitution principle, or LSP. The textbook definition goes something like, objects of a superclass should be replaceable with objects of a subclass without breaking the application. Sounds reasonable. If a duck inherits from bird, you should be able to use a duck anywhere you use a bird. Make sense? So developers everywhere start creating inheritance hierarchies. A square is a rectangle, right? They both have 4 sides. Let's make square inherit from rectangle. And that's where things go wonderfully, hilariously wrong. So here we have the classic rectangle square problem. Here's the classic example. You have a rectangle class with width and height, and you can set them independently. That's perfect. Then you create a square class which inherits from the rectangle. But wait, a square's width and height must always be equal. So when you set the width, you also set the height. You're maintaining the square's invariant, so you're being a good programmer. But now look what happens. You write a function that takes a rectangle, sets width to 5 and height to 10, and expects the area to be 50. So you pass in a square, width becomes 5, height becomes 5, because it's a square, and area is 25. Your function just broke. Your tests are failing, and your geometry teacher is crying. This, my friends, is a violation of the Liskov substitution principle. And it happens because we're confused is a relationship in the real world with is a relationship in code. So why this happens, the real problem. So why does this keep happening? Because we're taught to think in terms of real world relationship. A car is a vehicle. That's sure in real life. A manager is an employee. In the org chart, maybe. A square is a rectangle, says every geometry textbook. But here's the kicker. LSP isn't about real-world relationships. I'll say that again. LSP is not about real-world relationships. It's about behavior. It's about contracts and expectations. A rectangle in your code has a contract. You can set my width and height independently. A square can't honor that contract because its width and height are coupled. Therefore, a square is not a rectangle in code, even though it is in geometry class. So, what happens when we get LSP wrong? Consequence 1, we have fragile code. Your code becomes a minefield. You can't trust your abstractions. You start adding runtime type checks. If this is a square, do this special thing. Consequence 2, violated assumptions. Functions that work with base classes start breaking with subclasses. Your unit tests pass individually but fail in integration. You spend hours debugging why your perfectly logical inheritance hierarchy is producing garbage results. Consequence 3. Shotgun surgery. Every time you add a new subclass, you need to hunt down every place that uses the base class and add special classes. One change, 30 files modified, and your teammates start leaving passive-aggressive comments in code reviews. So, how do we actually apply LSP? Rule 1. Think behaviours. Don't ask, what is this thing in real life? Ask, what are the behavioural contracts and can this object honour them? Rule 2. Respect preconditions and postconditions. A subclass can't require more than one parent. A subclass can't require more than the parent, stronger preconditions, and must provide at least as much as the parent, weaker postconditions. If a rectangle says width can only be a positive number, square can't say width must equal height. Rule number 3. When in doubt, use composition. Can't make it work with inheritance? Use composition in head. Make square and rectangle independent classes that may be implement a common interface like shape. No broken contracts and no violated expectations. So let's have a look at the real world example. Instead of square inheriting from rectangle, we could create a shape interface with a getArea method. Both square and rectangle implement shape independently. Each maintains its own invariants without breaking the other's contracts. Now you can have a list of shapes, call getArea on each, and everything works perfectly. Square stays square, rectangle stays rectangular, and your code stays sane. This is composition over inheritance in action, and it respects LSP because each implementation honours the shape contract. I will give you my area when asked. So here's the takeaway. The Liskov Substitution Principle isn't about real-world relationships. It's not about inheritance for the sake of inheritance. It's about honouring contracts and maintaining behavioural sustainability. Before you create the inheritance hierarchy, ask yourself, can the subclass truly substitute for the parent without violating any expectations? If the answer is, well, mostly, or with a few special cases, then inheritance is the wrong tool. Your future self and your teammates will thank you for choosing composition instead. So, in closing, that's a solid principle everyone gets wrong explained. If you found this helpful, smash the like button and subscribe for more software engineering content that actually makes sense. Drop a comment below with your own solid horror stories. I know you have them. So, thanks for watching. See you in the next video.